Hello everyone watching this video. This is an introductory video on probability. What is probability? Probability chance. Probability is literally a technical term, a statistical term given to chance. What are the chances? कुछ भी होने का चांस क्या है? हम जा रहे हैं, हमें ट्रेन पकड़नी है. What are the chances कि हम वो ट्रेन पकड़ लेंगे? What are the chances वो ट्रेन लेट होगी? What are the chances कल हम टाइम पे कॉलेज पहुंचेंगे? What are the chances कि इंडिया अगला मैच जीत जाएगी? तो ये सारे चांसेस, और इतने बड़ी बड़ी बातें नहीं. In routine also, what are the chances that you will take 5 minutes to your work? What are the chances that you will take 7 minutes to your work? So these chances, now these chances are used very casually in our language. जैसे कि I am 99% sure that I will be there at the party. Now when you say 99% sure, if someone asks, where is that 1%? How do you reach this number of 99%? Why is it not 95%? Why is it not 98.5%? So what is our reply? Now when we say that there is 99% guarantee, 99% chance that I will be there on time, we mean that we will be making our best effort. There is no reason why we will be late, and because there is no reason that I want to be late, I have any work, there is almost 100% chance that I will be there. We are giving that leverage, we are leaving that 1% or 1.5 or 5% to the chance. What chance? Something may go wrong. When you come out to go to your workplace, you see that you have a flat tire, and that flat tire causes you, or rather costs you 5 minutes. पंचर टायर देख करके हमारे 5 मिनट वेस्ट हो जाएंगे. तो इसलिए वी आर लीविंग दिस 1% टू चांस. मुझे नहीं पता, आई एम नॉट श्योर. From my side, I am 100% sure. 1% we are not sure what could go wrong. Maybe गाड़ी स्टार्ट नहीं होगी. So we are leaving that to chance. So जो हम casually use करते हैं chance, उसको अगर हम statistically पढ़ने की कोशिश करेंगे तो that becomes probability. That chance is better explained in statistics, या taken care of in statistics by probability. What is the probability? Now probability in loose terms is chance. When we go ahead and study probability, we can see that broadly there are 3 approaches how we identify these chances. How do we find out these chances? There are broadly 3 different approaches. First one of those approaches is the classical approach. The very simple classical, how things should be, how in a controlled environment, in a very known environment, things should be, classical probability. Then we have relative frequency. Approach. Now this is rather at times called empirical, or also called statistical. And last one is subjective. So we have 3 different approaches: classical, relative frequency, and subjective. Now classical is the most pure form of probability, as things should be. Classical is the probability applicable only in very controlled and known environments, where everything is known. Like outcomes are known. All possible outcomes are known, and all possible outcomes are equally likely. Equally likely means all outcomes have equal chance of coming. Like when we toss a coin, head and tail both have equal chance. When we roll a dice, 1, 2, 3, 4, 5 and 6 all have equal chance. So all are equally likely. There is no way that you will be getting 1 more times. There is no way that you will be getting half of the times you will be getting a 3. No, it doesn't happen that way. If you roll a dice 6 times, it is expected that you will be getting a 1, 2, 3, 4, 5 and 6 on each of the trials. Then what is relative frequency or empirical? Now as we see, this is also called statistical probability. Now when we come to statistics, it will definitely be based on some gathered data. There will be some data, and based on that data I will be giving my probability. Where does that data come from? That data comes from experiments. Now in probability, what do we mean when we say an experiment? Experiment is something that you do. The question that you are trying to answer, that definitely must have happened prior to that also. So whenever that thing happened, that was an experiment. Like, for example, what is the probability that tomorrow we will be on time? Now if we talk in terms of classical, students generally make a mistake of answering as 50% possibility that I'll be on time. 50% chance that I'll be on time. Because they assume that 50% chances that I'll be on time, 50% chances that I'll not be on time. So they say 50% chance of me being on time. But this does not follow this second condition. Equally likely. Being on time and not being on time should be equally likely. Do we agree that being on time and not being on time are equally likely? No. Being on time is more likely to be there. ज़्यादातर हम क्या होगा, अगर हम 10 दिन कहीं पे जाते हैं तो 6, 7, 8 times तो definitely will be on time. Yes, there is a possibility कि हम कभी time पे ना हो. तो इसका मतलब जो ये experiment है, probability of being somewhere in time, this is not equally likely. तो अब जितने भी दिन हमने अपना डेटा रिकॉर्ड किया, हमने चेक किया कि पिछले 10 दिन से हम अपना टाइम मॉनिटर करते हैं कि 10 दिन में हम कितनी बार टाइम पे पहुंचे, हाउ मेनी टाइम्स आई वाज देयर ऑन टाइम. तो डेटा फॉर दोज 10 days, फर्स्ट डे ऑन टाइम, सेकेंड डे ऑन टाइम, थर्ड डे लेट, ऑन टाइम, ऑन टाइम, लेट, ऑन टाइम, ऑन टाइम, late, on time. So these 10 are your experiments where you gathered data. And now what are these experiments telling you? That in last 10 days, 1, 2 and 3. 3 times you were not on time. 1, 2, 3, 4, 5, 6, 7 times you were on time. So what does this relative frequency approach suggest? Because it is a statistical approach, it suggests that chance of being on time tomorrow is 7 by 10. While classical would have suggested that chance of being tomorrow on time is half. That is not the case. We all know that more often than not we are on time. So why does this happen? Because the events in this experiment of being there on time are not equally likely. Being there on time is more likely than not being there on time. सही टाइम पे पहुंचने का ज़्यादा चांस है एज कम्पेयर टू सही टाइम पे नहीं पहुंचने का चांस. इस रीज़न से हम कहते हैं कि दीज आर नॉट इक्वली लाइकली. दोनों का चांस बराबर नहीं है, दोनों इवेंट्स का, दोनों आउटकम्स का. सो फर्स्ट अप्रोच इज क्लासिकल अप्रोच व्हेन आउटकम्स आर नोन इक्वली लाइकली. रिलेटिव फ्रीक्वेंसी अप्रोच और एम्पेरिकल और स्टैटिस्टिकल. All of these approaches suggest that there will be certain data collected. And the data will be coming from experiments. So will be performing certain experiments. Like here, these were the experiments. 10 experiments were done. I recorded my data on 10 days and I came out with this conclusion that 7 out of 10 days I was there on time. So it is expected that tomorrow also I'll be having a probability of 70% or 0.7. Probability of 0.7 or 70% chance. Then last one is subjective. What is subjective? Subjective is some probability that has a backdrop of classical or relative frequency, but the answer or the result comes through my personal opinion. Personal opinion or experience or judgment. So what is subjective approach? Subjective approach is an approach where I start with classical or relative frequency. Definitely my knowledge or my experience is coming from classical or relative frequency, but then I make use of my opinion, my experience, my judgment, how I have seen things all my life. I use all these things to give some subjective probability, like the answers that we started with. There is 99% chance that I'll be there on time. What is this 99%? This is a subjective probability. This is not relative frequency because I have not monitored. 99% would have been relative frequency if I had monitored my last 100 appearances. And then out of those 100, I was there on 99 occasions. So this is not exactly relative frequency, this is not exactly classical, but it is subjective. Yes, definitely in this case also, when I am saying कि कल मैं 99% chance है कि time से आ जाऊंगा, there is an element of relative frequency because more often than not I have seen that I am on time, that our teacher is on time. So we are giving it a very high chance. This high chance from our side is 99%. This high chance from someone else would be 95%. This high chance from someone else would be 80%. So these are subjective chances. In the same class, if you ask whether the teacher will be on time, someone will say 99%, 95%, 80%. There will be people who will be saying 100%. There will be people who will be exaggerating it by saying 110% chance hai. He will be there on time. So this is subjective. Subjective वो जो हम past देखते हैं classical से या relative से कुछ सीखते हैं and then we give our opinion. What is the chance that India will win the next match? इसमें हम क्या देते हैं 80-20, 60-40. ये जो 60-40 है ये आपने chance दिया है, express किया है कि you feel that given India's form, given conditions in which India is playing, there is a higher chance of India winning the game. Now, what about classical? So subjective. First let us talk of subjective. Subjective is done. Subjective is derived from classical and relative experiences and then clubbed with your opinion, experience and judgment. Now let us talk of classical probability. Classical probability is when we know the outcomes. The outcomes are known completely. You know exactly what outcomes are possible and all the outcomes are equally likely. Like when we drop a pen from, let's say, 3 feet. You drop your ball pen from 3 feet. What are the chances that it will break? Or rather, instead of calling it break, let us say, what are the chances that the pen will be in working condition after that fall? Now the outcomes possible are, it will be in working condition or it will not be in working condition. But they are not equally likely. Depending on the build of the pen, if it is a fountain pen, there is a higher chance that it will break down. It will not be functional. If it is a roller pen, there is a high likelihood that it will not be functional. But if it is a ball pen, there is a good chance that it will be working after 3 feet fall also. So because the chances are not equally likely, that will go in relative frequency. We will perform that experiment, we will drop that pen, we will drop 10 different pens from 3 feet and monitor what happens to them. And then we'll give our probability. So we'll be having classical probability, relative frequency approach and subjective. Subjective we are keeping out of our discussion from here on, because after learning through classical and relative, you can give your subjective opinion. Now, when we proceed with probability, there are certain terms that will come in our way. First term that we just talked about was experiment. Experiment is you performing your experiment. Whatever is the question, when you make a trial for it, that is known as experiment. Like, what is the probability that the pen that you are dropping from 3 feet will be functional after that fall? Now this becomes our experiment. Now you could repeat this experiment 4 times, 5 times, 10 times, 100 times. So if you are dropping that pen 100 times, it will be known as that you have performed 100 experiments in this case. Whenever you perform an experiment, there are bound to be certain outcomes. Like when I drop the pen, outcomes could be that the pen will break or it will not break. Or there could be other outcomes also, that it doesn't break but it is not operational. Not breaking but not working also. Pen breaks. Pen breaks but refill operational. So there are n number of outcomes possible. So whenever you perform an experiment, there will be certain outcomes. If we have a list of all possible outcomes, that list is called exhaustive list. Exhaustive list of all outcomes. And of those outcomes, you could have favorable outcomes and unfavorable outcomes. What do we mean by favorable outcome or unfavorable outcome? Now, favorable and unfavorable here are not our personal choices. It is not something that I wish that is favorable. I do not wish this to happen, so it is unfavorable. It is not my personal choice. Favorable and unfavorable here means what the query is about. If the query is about breaking of a pen, then breaking of a pen becomes favorable outcome. If the query is about incidence of a disease, then incidence or contact of the disease becomes favorable. So favorable and unfavorable has got nothing to do with what we wish, what we desire. Favorable and unfavorable depend upon the query. What is the query? So we'll be performing an experiment, doing that thing what we were checking when we talk of incidence of a disease. So we'll be going out there and checking if a person is in contact with disease, if another person is in contact with disease, if another person is in contact with disease. So we'll be checking everybody. Those are experiments. And when we check a person, whether he is in contact with disease or not, then there will be outcomes. What are the outcomes possible? He could be in contact with disease, he may not be in contact with disease, he may be vaccinated, he may not be vaccinated. These are the possible outcomes. He may be vaccinated and still in contact with disease. He may not be vaccinated and not be in contact with disease. So these are all possible exhaustive list of outcomes. All these outcomes, favorable would be being in contact of disease. For example, vaccinated and in contact of disease, not vaccinated and in contact of disease. So these become your favorable events, and whatever we are not talking of become unfavorable events. Then another two terms are mutually exclusive, and non-mutually exclusive. Now, what are mutually exclusive and non-mutually exclusive events? Mutually exclusive events are events in which happening or occurrence of one event prohibits happening or occurrence of other events. So, in mutually exclusive events, if one event has occurred, it means that second, instead of event, let us call it outcome. If one outcome has occurred, then there is no way that the other outcome can occur. For example, if a head has turned up, it is just not possible that tail will turn up. Head and tail are mutually exclusive. If head comes, no way tail can come. If tail comes, no way head can come. Then when you use cards, king and jack. If a king comes, there is no way a jack can come. If a jack comes, there is no way a king can come. Then when you roll a dice, odd and even. If 1, 3 or 5 comes, then it is an odd. And if 1, 3 and 5 have come, then definitely 2, 4 and 6 cannot come. So an even cannot happen. So any number which you pick, it will either be odd, and if it is odd, definitely it will not be even. If it is even, for example 4 is even, so definitely it cannot be odd. So these are mutually exclusive events when one occurrence or happening of one outcome prohibits or stops occurrence or happening of another outcome. Then there are non-mutually exclusive events, like in cards itself, let us talk of a king and heart. Does happening of a king prohibits happening of heart? No. There can be cards which belong to both heart category and king category. In fact, there is one such card which if you draw, you'll say that yes, it is a king. You'll say that yes, it is a heart. So heart and king, these are two events or outcomes which are non-mutually exclusive. They can happen together. In roll of a dice, let us say more than 4 and even. More than 4 and even. Are these mutually exclusive? More than 4. What are more than 4? We have 5 and 6. What are even? We have 2, 4 and 6. Are these mutually exclusive? No. There is a 6 which is part of both the lists. It is featuring in more than 4 also. It is featuring in even also. So this is a non-mutually exclusive experiment or event. This experiment has non-mutually exclusive outcomes. It will be better if we call them outcomes. So these were certain terms that we come across when we study probability. Experiment, outcome, favorable and unfavorable, mutually exclusive, non-mutually exclusive. Let us some mark. Experiment, outcome, exhaustive list of all outcomes, favorable outcomes, unfavorable outcomes, mutually exclusive outcomes and non-mutually exclusive outcomes. These were certain terms that we will come across when we study probability. Now, there are certain rules in probability. To start with, there are two basic rules. One is addition rule, another one is multiplication rule. Addition rule and multiplication. Now, what is this addition rule? Addition rule is used whenever there is or in the condition. Whenever the query has an or built into it. Multiplication is used whenever that query has an and built into it. So whenever you come across or, we'll go for addition. Whenever you come across and, we'll go for multiplication. So how do we write? Probability of A or B is equal to probability of A plus probability of B. For mutually exclusive events. If your outcomes are not mutually exclusive, then probability of A or B becomes probability of A plus probability of B happening minus probability of A and B happening. This is applicable for non-mutually exclusive events. So we have two approaches basically for addition rule. Mutually exclusive events, it is only PA plus PB. Non-mutually exclusive, it is PA plus PB minus PA and B. Let us go ahead and see what is this addition rule. Now if we have a look at addition rule, let us reframe it. Addition rule. It is P, A or B is equal to PA plus PB. P, A or B is equal to PA plus probability of B minus probability of A and B. First one is applicable for mutually exclusive outcomes. And second one is applicable for non-mutually exclusive outcomes. Now in statistics, there is another representation for this which looks more apt when we are studying statistics. That is PA union B is equal to PA plus PB and is represented by intersection here, PA and B. So it becomes probability of A union B is equal to probability of A, probability of B and minus probability of A intersection B. So this is our addition rule. Now what is this addition rule? Let us check. What is the probability that you will get a king or an ace? Now first thing, is it a mutually exclusive experiment or non-mutually exclusive? Mutually exclusive matlab, does happening of king stop A from happening? अगर किंग आ जाता है तो एस आ सकती है क्या, इक्का आ सकता है क्या? देयर इज नो वे किंग आ गया है तो इक्का आए. अगर एक पत्ता है जिसको आप किंग कह रहे हैं, बादशाह कह रहे हैं, तो वो पत्ता इक्का नहीं हो सकता। इसका मतलब इट इज नॉन म्यूचुअली एक्सक्लूसिव। तो फॉर्मूला क्या रहेगा हमारा, प्रोबेबिलिटी ऑफ किंग और की जगह लगा देंगे हम प्लस प्रोबेबिलिटी ऑफ एस। प्रोबेबिलिटी ऑफ किंग कितनी होगी, 4 आउट ऑफ 52। अभी ये प्रोबेबिलिटी हम सीखेंगे, फॉर नाउ जस्ट लेट अस यूज दिस 4/52। तो ये टोटल हो गया आपका 8/52। फिर अब एक क्वेश्चन और हम देखते हैं, प्रोबेबिलिटी ऑफ किंग और हार्ट। तो अब ये नॉन म्यूचुअली एक्सक्लूसिव है या नहीं, ये म्यूचुअली एक्सक्लूसिव नहीं है, ये नॉन म्यूचुअली एक्सक्लूसिव है। नॉन म्यूचुअली क्यों है, क्योंकि कोई ना कोई एक ऐसा कार्ड है जो दोनों है, किंग भी है और हार्ट भी है। कौन है ऐसा, कितने हैं, ऐसा एक कार्ड है। सो इसका आंसर क्या होगा, प्रोबेबिलिटी ऑफ किंग प्लस प्रोबेबिलिटी ऑफ हार्ट माइनस प्रोबेबिलिटी ऑफ किंग एंड हार्ट। प्रोबेबिलिटी ऑफ किंग कितनी हो जाएगी, 4/52। प्रोबेबिलिटी ऑफ हार्ट हो जाएगी 13/52 माइनस प्रोबेबिलिटी ऑफ किंग एंड हार्ट। ऐसा एक कार्ड होता है जो कि किंग भी होता है हार्ट भी होता है, दैट इज किंग ऑफ हार्ट्स। तो इट विल बी 1/52। तो ये टोटल हो जाएगा हमारा 4 + 13 17, 17 - 1 16/52. So here we see that this was a case of mutually exclusive and this was a case of non-mutually exclusive. So this is how our addition rule pans in probability. Then there is a multiplication rule too, which suggests that probabilities should be multiplied. Probability of A and B should be probability of A multiplied by probability of B. The probabilities get multiplied. Like, let us take a question for this also. Example. So what is our multiplication rule? So let us say probability of A being on time is 9/10. Probability of B being on time is 8/10. So what is the probability that both A and B will be on time? Now my query is probability that A and B both will be on time. Both will be on time means A will be on time and B will be on time. So it is, what is the probability that A and B will be on time? So it will be PA multiplied by PB, giving me 9/10 multiplied by 8/10, making it 72/100. So 72, on 72 instances out of a total 100 instances, A and B both will be on time. This is what we expect out of this query. So we have a addition rule and multiplication rule. Then we'll have a separate video for a discussion on marginal probability, joint probability and conditional probability. So our next video will be talking about joint, marginal, conditional probabilities in case of statistically dependent and statistically independent experiments. So this was it for introduction of probability. A PDF of all this that we have written over here will be available on our website adityclasses.co.in. You can go download it from there. The link for the download will also be available in the description. Thanks for watching. Bye bye. Here are some cards related to the video you just watched. Feel free to browse across them and do leave your comments and suggestions. And of course, don't forget to subscribe if you have not already subscribed. Thanks for watching. Bye bye.